This is our last example of two variable statistics linearizing, and there was much rejoicing. Not as much rejoicing as if we were to eat Robin's minstrels, but nonetheless rejoicing. So here we have our data. We check to make sure that both columns are on the increase, and they are. We then check for proportionality. From 1 to 2 is a doubling. From 2 to, uh-oh, that's not a doubling. Check one more, just to make sure that we haven't missed something. How about let's go from 3 to 6. From 3 to 6 is a doubling. That would be 3.5. That should be about 7. Whoa, not even close. Who's having trouble keeping up? That would be the period. So the period, if you've done a little bit of physics, often the period is symbolized with the variable capital T and the length of a pendulum, some kind of L, lowercase or uppercase, it doesn't really matter. But we decided that the period is having trouble keeping up. So now we're going to make a new data column with the square of that. We're going to square the variable, we're going to square the unit. So 2 squared is 4. I can do that in my head. Actually, I can square all these in my head, but there are little mathematical tricks that you can employ to do this, but I've written them down on this extra piece of paper here off to the side, just so that we do this quickly and I don't make any mistakes, because I do sometimes. All right, once we've modified this data column, we're no longer interested in that. I like to put a line through it so that I don't have a brain fart and accidentally put that data column into my calculator. Now, let's check for linearity again, proportionality. 1 to 2 is a doubling. 4 to, that's about a doubling. Try 1 to 3, that's a tripling. 1 to 3, tripled. 4 to about 12, that's a tripled. Okay, looks good. Now we decide who is the rise and who is the run. And the way we do that is we look at the units. What unit makes more sense? Meters per second squared or second squared per meter? Hopefully you recognize meter per second squared as being the unit for acceleration. So I think we want these to be our y values, rise over run. So when we put these into our calculator, the t squared values are going to go in the first column. My old faithful calculator here. Let's go into stat mode. We're going to edit by putting some numbers in. Now I've already put those in. You can see that I've put 4, 7.84, etc. into the first column, which by default is the x value column. And then I've put all the links, that was easy to type in column L2. Looks good. Let's quit by hitting the second button and then quit. Now we're going to hit stat again. Go back into stat, but now we're going to calculate. We're going to go down to number 4, linear regression, enter. Everything is set up the way I want it to be, so I'm just going to hit enter here, and here we go. Here's the equation that has emerged. Y is equal to roughly 0.25x plus 0.007. Now, for the last time, don't leave these as generic x and y. You need to use the variables that are in the problem. So the y values here are L. I'm going to leave the 0.25 there as it is. But what's x? Now, x is not t. X is t squared. So put that in there like that. Once again, often this intercept is a pretty tiny number. So it's often safe to say, you know what, the linear regression equation, we're just going to say is L is equal to 0.25 times t squared. That's how you do it, people.